equate the two curves.
Very good. You equate the curve to the line. Make y as the subject for the line, and then that's it. Tell me what you're getting. What's your solution, Nabil?
Wait, miss. X is minus 3 and x minus 3 and 2x minus 3.
Okay, correct. The question only wants the x coordinate of A and B. So you have to specify. You cannot just write x equal to 3 and x equal to 3 over 2. You must tell which matches with which one. So which is the B, boy?
The B, x equals 3.
Yeah. Okay. Cynthia, what does the second question wants now?
Equation of the tangent
To the curve at B. Can you tell me the form of equation of a tangent?
y equals to mx plus c.
Very good. So what is your first step? How to find the gradient of the tangent line?
dy dx x squared minus 4x plus 7.
Okay. Then at B, substitute. I think you know this. I know the x. Isabel, how to find the y value to substitute? The x is 3. Where will you substitute the 3? Is it the line or the curve?
The line.
Very good, because it's much easier. If you want to put in the curve, can, but it's a little longer. So what is your y value, girl? Put 3 into this, what is your y? Y? 3 plus 5 divide by 2, what do you get?
F4.
Yeah, 4. So you do the 4. Okay, that is the equation of the tangent, done. And now what I'm interested is actually question C, the C. Maybe this is extension of yesterday's idea. I want to see whether you can capture the concept or not. Now they said you need to find the angle in degrees, correct to 1 decimal place, not relevant information, between this tangent and the line 2y equal to x plus 5. Okay, that is already given to you here. One of it is given to you. Now Warren, which steepness is greater, the tangent or the given line here?
Tangent.
Very good. You see a 2 here. But for this particular line, it's just half. Okay. So what you're going to do, you're going to try to simply sketch. I mean, you just have to do something like this. You just extend. So this is your tangent line because the steepness is higher, right? Higher. So higher means it needs to lie on top of the line AB. So let's extend the idea here now. So I know this is my 2x minus 2. And the question already having, let's just extend this way, y half x plus 5 over 2. Now they want me to find the angle in between here. How? Okay, let me ask Ladisha. Ladisha, if I want to find an angle based on the gradient, what concept I use?
Tangent.
Very good. Tangent theta. So you help me to create a parallel line exactly at the intersection point. Okay, exactly at the intersection point, you create a parallel line to the x-axis, meaning something like this. Why am I asking you to create a parallel line? So that you can see the angle easily. So what I'm going to do, I'm going to take this big angle, theta, and I'm going to minus this small angle. Let's say that is alpha. If I take the big angle theta and minus the small angle alpha, I will get the angle in between them. This is the idea. So what we're going to do, we're going to find this big angle first. Find this. Okay, let me rename, yeah. I put here theta, you might get confused. Let's put this as beta. So find the beta. How to find the beta? Help Richie. How to find the beta? Hey, where is Richie? Oh yeah, he's there.
10 beta equals to 1/2.
Is it 1/2 or 2?
Wait, beta or theta?
Beta.
Oh, beta 2.
Very good. Okay, then write another statement for the alpha. The alpha is somewhere down here, right? This one. So if you want to find this angle, this is, let's label this as alpha. What is tangent alpha, Sri Raharjo? Sri Raharjo ignored me. Tangent alpha is what, Sri Raharjo? If you still cannot see, you can think like that. You take it out and then you just put a line like that. And you know this is your alpha, and you know the slope for this line is what? Half. Remember yesterday's concept? Same thing. So you can write on your own. Tangent alpha is exactly half. If you cannot see, you split. You try to think differently. Like same thing I have here, still the same axis. But now I'm having a bigger one. So this one is what I label as beta. And then you find the angle in between. Any question? Some of you look puzzled from the screen. Okay, unnecessary, I erase this, yeah. Therefore, your theta will be beta minus alpha. Tangent inverse 2 minus tangent inverse half. Help with the answer, Gabby. What answer are you getting? Correct to 1 decimal place.
Zero 0.64.
Are you sure your calculator mode is in degree or radian? How can the angle be so small? You want to try again?
$36.9.
Very good. Russell, open camera. Why is Vincent is already there? Are you okay? If you understand, please put a thumbs up. If you understand what's happening. Okay. Okay. Actually, there's many ways to solve this question. You can even use vector. I mean, I don't know how much you remember vector from your IGCSE, so I'm not doing that. And then you can also use trigonometry formula. Remember the tangent A minus B, also from IGCSE. You can also use that to solve. But I don't want to teach you all that. Maybe when we are done revising all the chapter for MYE, I can tell you bigger ideas. For now, you stick to this concept. Okay, then part 2 is simple. Again, chapter 1. Try. Hanson, can you read the question for the class?
Determine the set values of k for which the line 2y equals x plus k does not intersect with the curve y equals x squared minus 4x plus 7.
Okay, what is the meaning of set of values of k? Can I leave my k in terms of equal sign, Hanson?
Yes.
Hey, set of values, range of values. You cannot go and say k equal to something, yeah? The answer has to be in terms of a range. Now, let's ask Jesselyn. Jesselyn, you look at the diagram and you tell me what is the k value in the diagram.
5.
Very good. When the key is 5, are they intersecting?
Yes.
Yes. So now the question wants you to find a k value. You need to find the possible k values which will make the graph detach. How? Something like this. You've got a curve there, but you want the line to be like this. So which k value will make it in this scenario? That's what the question wants. What concept is this, Nesha? Intersect at 2 points, intersect at 1 point, do not have any intersection. What concept is this? Starts with D. I.
Differentiation?
D-I-S.
S.
Yeah, this.
This place.
See. Okay, who want to help her?
Discriminant.
Yes, discriminant. You have to use discriminant concept. So if you want to use discriminant concept, it always works for quadratic. So equate the y. First you equate the y. There is a y here, there is a y here. Equate them. Get the a value, b value, c value. Use b squared minus 4ac. Why am I equating? I'm making an assumption that they will intersect first. And then I'm analyzing from there. How if they were to intersect? Oh, minus 9, yeah. Okay. Ivy, help here. What is my A value, B value, and C value, Ivy?
A is 2,
Hmm?
B is -9,
Correct?
C is 14 minus K.
Okay, good. So now we go and do B squared minus 4AC. Will I do less than or more than or equal, girl? What is the idea of discriminant here?
Less than.
Good job. Substitute, find the solution, done. Okay, I just do slowly so that you see. I don't like to expand, so I'm just bringing it the other side. And then I change the inequality sign because I'm going to divide. Should it be less or should it be more? Who want to help? Okay, I read your lips. Tell, less or more? No, lip is moving. Very good, less. Finish. So for any k value lesser than 3.85, you go back to the question, you put whatever k value you want here. If you put anything less than 3.875, they won't intersect. That is the meaning of the question. You can put k is equals to, let's say, -2. They won't intersect. If you put k equals to 3, it won't intersect. Okay, recap itself already took us 20 minutes. So now we're going to go to the new concept. You stretch. I'll give you 30 seconds. Drink water, stretch, finish up your work. Now you open the textbook, chapter 8. Open chapter 8. We extend. Now from now on, we're going to do application. In chapter 7, what did you do? Techniques of differentiation. And then you find the equation of tangent and normal. And then we learn second derivative. How to just do the second differentiation. Now we're going to look into increasing and decreasing function. What is an increasing function? What is a decreasing function? Please read what is written here, Jensen. Explore 8.1 of your textbook. What page, yeah?
113, yes.
Okay. Help boy, read Explore 8.1 for the class. Section A, increasing function.
Section A, increasing functions. Consider the graph of y equals 4 fx. Complete the following two statements about y equals fx. As the value of x increases, the value of y, the sign of...
Now we have to discuss.
Okay.
They already give you the function, the graph. It is drawn for you over there. Now you inspect along the x-axis. Okay, Jason, you will help me here. You look along the x-axis and you inspect what changes is happening to your y. Let's look at this. When the x value is something here, the y value is going to be this. And then when the x value is here, let's say, then what is happening to the y value as the x increases, boy?
It increases also.
Very good. As the value of x increases, the value of y also increases. Okay, now next, Warren, you read the second part. The sign.
The sign of the gradient at any point is always...
Okay, what do you think the answer is going to be? Let's back. I'm drawing tangent line here, let's say at this point. Then I have another point here, I'm drawing the tangent line. What is happening to the slope of this tangent line?
Getting steeper.
Very good, it is getting steeper. So what is the sign of the gradient?
Positive.
Good job. Positive. Because the steepness is increasing and it is positive. Okay. Now, second part is a bit complex. If you know, then you can do it. What does it say? Isabel, read for the class girl.
Number 2.
Yes.
Sketch other graph that satisfies this statement.
Okay, and
This
then
type
continue. Yeah. Continue.
functions called increasing function.
Okay. What is known as an increasing function? When the gradient keeps increasing. Okay, when the gradient keep increasing. And then they say you have to sketch. Now let's sketch how to sketch. Oh God, I'm just simply going to try to draw let's say quadratic. Do you think the gradient increases here, Vincent? At any point here, is my gradient increasing or something else is happening? Look at this. Can we draw something like this now? I got positive
No.
gradient. Yeah, because suddenly it is becoming negative already. From positive, it is becoming negative. I cannot draw this. So how? Anyone want to help me sketch? You y equals to ex exponential function. I think you can recall your IGCSE. Then you draw. Look at this. This is ex. The gradient always increases. It's always positive. That's why in IGCSE, when you differentiate any exponential e power x, y equal to ex, when you find the gradient, it gives you back the same thing. It's not like algebra where it changes. In the exponential, if you differentiate, you get back the ex. This is the reason. Because the gradient is just increasing. Okay, what else? How else can we sketch? Ln. The moment x, of course, I can draw ln x because they are inverse to each another. This is your This is your ln x. Also, the gradient is increasing. These are some example. Then later you go research on your own. In all these scenario, the dy dx is always more than 0, regardless of what point you are taking. Are you okay? Are you okay? Isabel, you look so bored. Okay, Sajida, you do the second part now. Decreasing function. Can you read?
Section D, decreasing functions. Consider the graph of y equal to gx. Complete the following two statements about y equal to gx. As the value of x increases, the value of y
Say it,
decreases.
good job. Good job, girl. Decreases, nice. Okay, continue.
The sign of the gradient at any point is always...
Try, look at this. Tangent going down. At this point, tangent line still going down. The slope is positive or negative, Sajida?
Negative.
Negative. So what is the sign of the gradient? Earlier when you did, the slope is increasing, right? So you said the sign is always positive. Now, what is the sign? It's like maybe this is -4, -3, -2. It's decreasing, but it's increasing negatively. But it's the gradient is still negative. So the sign is negative. Okay? You already know this. It's just an extension of IGCSE, but I'm just telling you by some experiment. Sketch other graphs that satisfy this statement. Then you can go back and sketch, you Google, do what you can research on your own. Okay, let's summarize. End of the lesson. So I want Jason to read. Jason, read. Now consider.
Now consider the function y equals to h bracket x shown on the graph. We can divide the graph into two distinct sections. Hx is increasing when x greater than a. What's I means?
I means something like an example. What
Oh,
does I stands for? Let me Google. I forgot. You keep reading.
dy dx greater than 0 for x greater than a.
They said it's a Latin abbreviation, but what is it exactly, i.e.? It seems it's in other words, but I think they have a shortcut for it. I mean, the long form of it, I don't know. You find out. Okay, now coming back to this concept, which you already know. See, for x greater than a, where is x greater than a? From this point onwards. From this point onwards, what can you tell about the slope? Slope is just keep increasing. What is slope's another name? Dy dx. And you know the slope is always positive. Finish, that is the meaning. For x greater than a, according to this graph, your dy dx is more than 0. So general idea, if you really don't know what's happening so far, you just write this. F is increasing function if f prime x is more than 0. You cannot write dy dx there because they said f. I started with f. F is an increasing function if f prime x is more than 0. So f is a decreasing function if f prime x is less than 0. Finish. Lesson over. Now let's try some example. You go to your exercise. I don't have the physical textbook, yeah, so it's difficult. You have to follow what I'm saying. Let's try question 1. E, 1E. What page is that? Can somebody help me? Who want to help me? What page is this? Please help.
$215.
250. Thanks, boy. Now what does the question 1? Can you also read? Find the
Set of values of x for which each of the following is increasing.
Okay, they already told it is an increasing function. We know that this is an increasing function. Okay, Warren, help. How do I begin? If a function is increasing, then what can you tell about the gradient?
More than 0.
Very good. What is more than 0? F more than 0 or f prime is more than 0?
F prime.
Very good. Okay, Isabel, can you please differentiate for me?
X squared
Okay, nice.
x plus 24.
Okay, solve. Quadratic inequality, again, chapter 1. So these are some prerequisite knowledge you need to know, yeah? Solve. Divide everything by 6. Factorize. Share your answer, Ivy. If those who want to stress, yeah, say.
X is lesser than 1 and x is greater than 4.
Yeah, you know, lies above the x-axis. Which part lying above the x-axis? This one and this one. So whatever Ivy said is correct. Good work, girl. Done. So if you were to draw the cubic, you know that it will be increasing for less than 1 and more than 4. We are not sketching, you are not seeing it. Let's try question number it's the same thing again and again. Yeah. Question 4, question 5. Question 4, 5, 6. Cynthia, read. Oh, Serafina, you haven't spoken for the day. Can you read, girl? Number 4.
A function f is defined as fx for over 1 minus 2x for x is greater than or equal to 1. Find an expression for f prime x and determine whether f is an increasing function, decreasing function, or neither.
Okay, help with the f prime x. What method are you using? Quotient or bring up?
Bring up.
Okay. What do you get?
8 times 1 minus 2x.
Very nice. I'll do slowly to show your friends, yeah. Very good because you managed to directly answer. I like when you can do that. Now they say determine whether f is an increasing function or a decreasing function or neither. So William, you help. They already given us f prime x. We just found f prime x. What can you tell about 8, boy? Is 8 a positive number or negative number?
Positive.
So you know it's always more than 0. 8 is always positive and it is definitely more than 0. Now you inspect the down. You have a square. You have a square here. Regardless of what x value you input here, for any x value or x element of real number, whatever you write. Oh, cannot. Can I simply put any x value? You cannot put half, okay? If you put half, it becomes undefined. That's why the question gave you this range. Look at this. They want x more equals to 1. So let's erase. Cannot simply say for any value. For x more equal to 1, 1 minus 2x squared is always what? Complete my sentence.
Positive.
Very good. Therefore, overall, f prime x is more than 0. Any question? What you must write in order to get mark this statement? They must see this. As usual, Varun became the inspector of the class. Why, Vincent? You look so not happy doing math. Okay, do 5 and 6 on your own. Then we quietly check our solution. Similar technique. Any question? So you cannot determine the sign of the gradient now. Sometimes it is positive, sometimes it can be a negative. It depends on what happens to my negative value. If the left hand side is, let's say, -1, and the right hand side, when you're solving, like here, you happens to get 5, of course the gradient is positive. But if your left hand side is -10, if this is -10, and this one is just 3, then you will get a negative value. So you cannot determine, will the output of the dy dx be always positive or will it be always negative? You cannot determine. Sometimes it is positive, sometimes it is negative. So no conclusion can be made about the f. It's not an increasing function, not a decreasing function. One more question, number 6. Read, Annabelle. Okay, I give you time after 30 seconds. If you're ready, then you can read.
Show that fx is equal to x squared minus 4 over x. This is an increasing function.
Okay, tell me the statement for increasing function, Annabelle. When can I say f is an increasing function? When it's gradient. You're not helping me. When is f an increasing function? When the gradient is greater than 0. So you have to find the gradient now. How to find the gradient for this? You want to use quotient rule or something else? Girl?
Quotient.
Okay, I will go with what you say. You want quotient means we can do quotient. But let's ask Jesselyn. Jesselyn, if I were to ask you, you think you will do quotient rule or will you do some other technique?
I put it into x squared over x minus 4 over x.
Okay, so she is using the splitting technique. I'll do both. Let's see what happens. You will get the same answer. So if you split, you can quickly do it. Therefore, f prime x is going to be 1 plus over x squared. This is if you use the split technique. Remember, I always say check. Don't always fall for the rule. Nobody likes rule. But if you really want to use the quotient rule, I will just show it here. I think after this done, what can you say? For x element of real number, 4 over x squared is always positive. 1 is a positive number. Therefore, you're right. F prime x is more than 0. So, f is an increasing function. Shown. But let's say if you're interested with the quotient rule, what happens? You use the rule, yeah, and then you differentiate. You get the same thing, see. You get square. So much more easier for you to write the interpretation. Either left hand side or right hand side, up to you. But the conclusion is still the same. Maybe some of you are telling, Miss, I don't know how to write all these. So how do I gain mark in the exam? You just write it in longer word. For X, for how do I say it? Yeah. For any x value, just write like that. For any x value, 4 over x squared is always positive. Don't go and do things like x equal to 1, x equal to -1. Don't do input and then check one by one. Don't do that. It's not a professional way of proving. You need to generalize now. You no more GCSE student.